Okay, no, nothing's changed really. Here we are. It's dark here and I'm squinting a bit because I've got this light and it's not really ideal, to be honest. I don't know what to do about it. I don't know what's changed in the last few days. Maybe that's better. Probably is with no light. Okay. Do look a bit grubby and filthy. If I turn that light on, we've got problems. If we move this light over my head, that's worse. If I do that to the camera, that doesn't help anything at all. Excuse me. That might be better. Anyway, we got bad lighting. I don't know, it's been a CAD week and it hasn't really been a productive CAD week, but it's been a CAD week. I've spent a few hours on CAD this week. There's always plenty of projects. Did find some drawings. We'll get back onto this hand plane project because it's nearly done and we'd like to get it finished. But beforehand, I've been looking at drawings. They're strewn all over the floor here, everywhere. I drug out a heap of drawings. Light rays are showing. So why are the light rays showing? Anyone got an idea about that? Is that better? Let's see how far up my arm I washed. Gosh, I need a shower bad. I'm filthy. Like, seriously. Gosh, I'm so bad. So dirty. Anyway. Drawing number one. They're huge. I found these in the cupboard and I've been messing around with them. This is beam engine. I don't know if it says beam engine in your to you guys because it could be back to front. I've been making hammer handles in the sweaty, hot, stinking temperature today, and I come home and I did a bit of wire wheel work, so that didn't help anything. So yeah, here we are. Anyway, beam engine, one of. Can we see that? It's mirrored. How do we change? Let's have a look. Video. Video input. Mirror camera. Let's unplug that and see how we go. Now we're back the other way. Which is strange. It blows me away. Anyway, now it says beam engine. How cool is that? Number 12, beam engine. OB Bolton, Sydney. Bolton, O'Burnaby Bolton was a optometrist in Sydney, and he sold a lot of steam engine kits. Some of them were, this isn't another project, just so we know, but just some background on this. Some of them were originals and some of them were copies of other things, like Westbury's Kitty Hawk and what else did he sell? copies of quite a lot of live steam locomotives that were Australianised, I guess, and stationary steam engines that were copies. But most of his stationary steam engines actually were originals, and I've got castings for quite a few of them. And I have the majority of castings for a number 12 beam engine, which is huge, right? The box of casting must weigh 25 kilos. And it's 20 inches wide long. That's full size. Give you some idea. It's got a 14-inch flywheel. So it's a bulky big steam engine. And it's nice. But being a beam engine, it produces, I thought, well, I'm going to go ahead and just cat it up, see what we end up with, see how it looks. Bit of a job. There's 4 huge sheets of drawings. That's the general arrangement. We're looking at, just for comparison, what have we got? Drawing number 2. Number 2's got a end view of the engine. It's got bearings, column in the middle there, and cylinder covers, all that stuff. Better just to look through the drawing from the back and show you. Cylinders, all that stuff. So that's drawing 2. Obviously, they were done over a period of time because they're all noted different and they're all a little bit different style. But this is number 3. It's got the beam and the governor. See that? It's a governor, conrod, flywheel, pump, and valve gear. I'm going to actually fold this one up properly. It's time. Fold this one up properly. There we go. And drawing number 4 has some details on it. So it's got the straight line arms and links, and what else? Some governor details and tablature details, regulator or regulator valve details, and big end details, basically, and some governor levers. So it's, fold this one up too, nicely, probably. I don't think that's exactly right. Anyway, so it's a nice engine. And I thought, well, I'm going to CAD this up because while I've got the drawings out, we might as well see how it looks. And there's some interesting animation and some very interesting CAD involved in the engine itself, because it has Watt's straight motion, and it's got basically 4 links that all operate from the flywheel to the piston. 5 links really with the straight line motion. Now, I'm not sure that I'm not going to do anything on straight line motion tonight, because I don't believe that it can be actually accurately CAD'd up. I don't think so, because I've got a feeling that it probably, because the drawings are all to the closest 1/64th. Everything's in 64ths, which is what, 16 thou, something like 15.5 thou, something like that. 15.7 thousandths of an inch. Is that right? I think that the tolerances on it aren't enough to make the straight line work in a perfect CAD model. I think it probably relies on some oversized holes and actually a little bit of positional error on the cylinder, etc., to make it actually work. So it's interesting. Hey, Mark. Good to see you. So that's Bolton's engine. Let's have a look at it, what I've done here while we're at it. You're going to get a blue screen here. There we go. So this is Bolton's number 12 beam engine. It's chunky. And we haven't quite got the straight line motion working yet. So there's some interesting things. This is disconnected. So what we can do is get a little circle of death because I'm not sure how much internet we've got. But we've got that bit working, right? We don't as yet have the straight line engine or the cylinder going up and down, but we have that going. So I've spent a little bit of time on this, and it's sort of a nice engine. There are other issues with it. As far as actually building the thing, there's things about it that make it complicated. It's a Bolton engine, so castings are available, the ones I haven't got. It's big. You need big machinery to do it. The base is like 20 inches long. And the fly inches, 13.78 or something, the drawing says. Beam's about 14 inches long. And the column itself weighs probably 5 or 6 kilos. And the base bed probably the same. The beam's probably 3 kilo sort of a casting. The fly was probably 4 or 5 kilos. So it's a lump of a thing. But the issue is it's got an outrigger bearing. An outrigger bearing is not connected to anything at the moment. It's not shown on the drawings of where you would connect it. So that's very nice, but it's not self-contained. So you've got to have a base that's at least this sort of dimension. If we have a look. 6.5 inches, something like that. 6.5 inches deep with a cutout for the flywheel and another piece over here to support this outrigger bearing, which is something like this. So it needs another piece of base here. Now, whether Bolton's ever made a big cast base for it, there's a good chance that they did, because I've seen something similar that's not in their catalogue for the number 7 engine, which also has outrigger bearings, which is a horizontal engine. I've got drawings and most of the patterns. I haven't got castings, but I've got most of the patterns for that. So how you would make a base here, like a big, huge, either a wooden base, or you laminate something up and put a cutout here for the flywheel, something like that. So make a box, hole in the ground, that's what it needs, yeah. So I think you'd make a a decent box here and laminate that up out of timber. Bit of red iron bark or something would be nice if I got the facilities now to do it, if this ever happened. And then cut a groove in here, the shape of the flywheel, quarter of the flywheel. You don't want a groove like this because then, I don't know why I'm saying this, but you don't want a groove that's the full thickness of the flywheel because this fills up with oil and dirt and stuff and you can't keep it clean. You've got to take the flywheel out every time you want to clean it. So if you just a quarter of this and have the flywheel open on one side and probably steps up the side. Now this isn't a huge, the prototype is not, gosh, I'm dirty. Sorry guys. The prototype is not a huge, big engine, to be honest. Thought it did say how big the prototypes. The prototype is installed at Oakhampton Waterworks near Maitland in New South Wales. About 1880, 15 and 16 horsepower engine. Didn't really say, but looking at it, I would imagine that with the levers and things on it, it's not a huge engine. Like really, it's not. Maybe looking at it, 15-foot flywheel, something like that. So it's not big. If we said it had a 15-foot flywheel, that's about 2-foot bore. I guess that translates to about 15 horsepower. And the whole thing, yeah, it's not big. So it'd want a ladder up the side of it or a set of steps or something and some handrails and things, I guess, eventually. And it'd be a very nice engine. But it's got Watt's straight line engine, and catting that up is a bit of a challenge, actually. If we look at it, here, these bits, we've got most of the bits all made. It's got 4 of these fancy links with the bearings, split bearings, and ledges. So it's because it's big, the engine's very full-size practice. It's not a model by any means. Everything's got captive ramps and wedges in all the linkages to hold all the bearings together, things like that. It's all got proper bearings in. It's got proper bearing, like proper bushes in the valve gland and a wear piece and all that. Pretty decently designed model, and not that complicated. If you have a look at these bearings, very simple castings, and big end, of course, with proper captive ramp in here, and then a tapered wedge to hold the horseshoe on, and then that holds your 2 halves of your bearing onto the crank. It's got 12 pretty decent bolts to hold it together, hold it down, and all the valve gear goes in here and is separate to the cylinder, so the steam chest is separate. and bolts on with all the passages in the steam chest. So it's a fairly simple thing in that way to build, but it's got some challenges in the motion. So this here is supposed to be vertical, and this one here, this bush here, if you can see that, is supposed to go on this pin. So there's another one of these goes here on, have a look, on this bush here and this pin. So there's one on there and there, and one on there and there. So looking at the front of it, we've got the side of it, there's pin there and a pin there. It has one of these parallel motion assemblies on each one. One there, one there, one there, and one there. And the four of them go up and down. And rock side to side, but they go up and down vertically as as this beam goes up and down. Those four go up and down with the beam, and then there's a anchor, I guess, an anchor bar there that is actually fastened. It's got some bushes onto the entablature or onto that arm there, and that means it gives you a line through here through the cylinder. So that's what's, I think it was patented, straight line mechanism. So nice little engine. That's what I've been messing with this week. I really haven't, I think I've had a reasonably productive week, but I have actually done a little bit of CAD work, and that's what it was. Just this pretty little beam engine to actually see how it looks and whether it can be CAD'd up and put it all together. This has got prototypical starting gear on it, so it's basically a notch in the eccentric rod. The eccentric rod sits over a lever here. Eccentric goes on here. I think I've put the eccentric on there. Yep. And the eccentric rod comes up here and sits over a lever and works backwards and forwards, and you lift that out to disengage the flywheel for starting, and then you can use another lever to independently move steam into the cylinder at each end to get it going, and then you drop the eccentric in to keep it running smoothly. It's also got bevel gears and a decent governor, like a really nice flywheel, what style flywheel governor, and that works on a valve on the cylinder on the steam chest to make basically a proper governed engine. So run pretty slow, I would imagine. So anyway, that's might be of interest to someone. We're sort of still playing with it. Haven't even thought about any of the detail that goes on here. To give you some idea, we click over here on where it says section view. We can section it like that. It's got a hollow column. That gives you some idea of the bits that I've actually got in place now, but there's still a lot of work in it. And I'll cut it up, and I don't know if I'll go any further with it, but it'd be a very nice engine to build if I had access to some bigger gear. But I think you're looking, the finished thing is about, let's have a look, let's see where we're at the moment. We can just do that with our mass and properties. There we go. As we're standing there, we're looking at most of these parts I've actually some of these linkages I'm still working on, but most of them have been basically labelled with the correct material, so this isn't far out. There's a list of things here, and 14.628 kilograms. So we're pushing 15 kilos as we are there, and there's no eccentric, no valve gear, I don't think there's any straight line gear in it at the moment. No governor, no nothing, and then a solid, like a decent base for it, and a ladder and some handrail stanchions and things. You probably are looking somewhere at around 20, 25 kilos for the engine. So it's big. Anyway, that's something we've been messing with. Just because we can, and because I needed to, I felt like having some downtime. And it might have been fun. With Carl's low angle block plane. If you can hear the printer going in the background, that's what's actually printing downstairs. This is that I've sort of, a friend at work and I have been playing with. I think potentially this is going to be a very nice tool. It's not anywhere near complete here yet. We haven't got the adjustable mouth in here. There's no real front knob on it. And there's no adjuster in it yet. We haven't actually got enough. This isn't far enough back or anything for an adjuster. And it feels a bit like it's, proportions probably aren't terrible, actually. We're just looking at that. But it'll be a broadcasting. And probably there's some fairly interesting sort of shapes, patterns and things in here, because it's a compound angle in here. So it's a skew blade. See, so it's got an angle this way on that line, and it's got an angle this way on that line. Some very interesting CAD work in here, and I guess that's where our Stanley 110 was heading. But that's 3D printing at the moment, and probably tonight I'll have it printed and put together, and we can have a bit of a look at it tomorrow. As far as I'm not sure if Carl's going to be at work or not, but probably it might be Thursday. Anyway. It's going to need some sort of a movement system to move or adjust the front. The adjust the mouth. Haven't actually thought that through, and it's having a noster in here, which is quite a simple thing, but there's not enough room there in here for it. So that's going to need a little bit of modification or improvement. It's got a plain blade, and then I think just a slot with a keeper, and with sort of a bit of a fancy bronze cap on the screw, and then just probably just a bolt to screw it down. So that's how that's going to work. And it's about a 2-inch blade, or a fraction more, a fraction less, 50 millimeters or something, to give it a little bit of adjustment. And I believe that it probably needs a little bit more work. I'm looking at this here, thinking I don't really like the shape of this here. I'd like to see this here come into the front here and have the front smooth all the way around, with this sort of curved off here and not this little angle gap in here, that shape. I don't like that very much. I think this is a bit boring where this is here, and it's probably all right, but whether it needs an actual bit of weight in here and a curve and a big radius, we're not sure. We're going to have to do something in the back here for the adjuster, so it means extending this out here. And whether we just go with the plain Stanley style grips like that, which sort of are in keeping with it. But then if you put a Stanley knob on it looks a bit like crappy. So that's another job that I've been messing with a bit. This is an actual real job. This is an actual project. And I guess if we get a couple of castings, I'll make one, and Carl's going to supply some bits and I'll supply the castings and the timber maybe. And he can supply, I think he offered to supply adjusters and blades and stuff. So probably 01 tool steel, and I've got the heat treat oven and all that stuff. We just got to machine it. It'd be nice to have 3-phase power at some point, but that hasn't happened yet. Anyway, that's another job. If anyone's sort of interested. Another job that we've just finished is actually translated into an actual real project, and it's getting very close to finished. Gee, it's hot here. Is this going to load for me? Are we getting audio and we're getting all that stuff? I guess so. To be honest, my internet's a bit crappy this week. Come on, do the thing. I'm going to refresh that page. Hopefully. It's loading workspace, so it might be doing something. I still look better. There's a feature in the parts list at the top, even though there's no parts or features in it. It would be nice if the power comes, to be honest. It's just a matter of organising it and having some money to do it. There we go. So this is, I don't know if you saw this, but this is actual pattern parts for a lever, or basically that's it. Have a look. If we go back to there. So that's it. With the writing on the side. A plate on there, another plate on there with a little 3 on it. This one's been lapped to within an inch of its within an inch of its life, and really I've machined it and got it back to cylindrical again, but there's not enough meat in there, and this hole's just about out of sight in the valve body because it's in too far. So we could plug this and silver solder it and remachine it and put it in and make another spacer washer to go on it, and it might be all right. Anyway, the pattern's finished. That's, yeah, I probably did show that last week. But that's a job for the foundry. What else I'm messing with? This all seems a bit procrastination-y and a bit sort of, it's stuff you do when you really can't be bothered going and actually making stuff out of metal, which feels like a cop-out. And I've spent a lot of my the last few months, anything I've done for myself or anything I've done for my projects. That's where I've been with this. This is a cover for the guard, for the launch. Let's have a look here. It's a bit serious, this. So for this guard here, we tried all sorts of things to put a taco on this. One of them was anyway, this is where we ended up with it. Is basically we've got this. And we can mount a taco in there, and we can drill off through the back here and have a very excellent Hall effect sensor pickup. Does anyone know enough about this to know a better way than having a magnet on the lathe headstock for a taco? I don't. But I bought a taco module in the end, which just fits this space nicely. The trouble is that the 7-segment LED display on it is not soldered straight on the board, so I'm going to have another go at that. Someone soldered in with a bit of a twist, and I don't know why that should be, because it seems to me that the pin should line up with the holes, and the holes all seem pretty square. So that's a soldering job to get that straight before we do that. But if we insert here the oh gosh, it's 1,000 parts here, but what's the new bit we've just done? Like so, and then we fasten it on there. Use a fasten mate here. Probably there, and the same there. And we haven't got that right. So let's close that and try again. Fasten mate on there. Fasten mate on there. There we go. So roughly something like that. It's sort of going to work with the taco display on it, and that's probably going to be fairly neat. And a couple of little Phillips head screws countersunk in there so that it looks the part. You could use a timing light rather than fighting magnets, Phil. I will talk about that. Yeah, Peter, we'll talk about that, because I'm not sure where. Let's put a section view of that and see if that's actually lined up. I might have to offset that because it seems to be further over one way than another. Put a section view in here, we can see that it doesn't quite line up. So let's fix that. We'll go down here to the last fasten mate, because none of these are labelled. This is an old drawing, and it's been a work in progress for some time. We'll make an offset there on the Z direction, 1 millimetre. That's probably all it needs. Let's go 0.6. No, 0.8. 0.8 looks like it's about in the middle. And it's sort of fixed it. It's going to need a little bit of adjustment there. But there's room in here to put that board off on standouts, like on nylon bushes with screws. And then there's room in the back to put a Hall effect or a timer night or whatever we need to do. You're not seeing my CAD. Sorry, guys. That's a bit crap. Thanks for that. There we go. Sorry. There we go. We'll start again. Here's the cover for the... Sorry, guys. This is a cover I've been working on for the guard on the launch. All right, this is the CAD work for the guard. And it's an old drawing. And this is the new cover, which is going to have the taco in here somehow. Probably cast in aluminium and then filled and painted. And you've got the head screws here to hold it in place. So this isn't really big enough here. It doesn't seem to line up nicely. We might have to have a bit of a play with that. Now I've actually put it in place. I've only just dropped this in the drawing to see how it works. And I believe that originally this cover, before I modified it, was stand out here. That was another option. And it's got a taper on it. So shortening it up means that this doesn't quite match up. So that's another thing that I've been sort of messing with. And I think that looks good. It sticks out sort of that far. It looks apart. There's room in there for the taco we're putting on the top here, so you can't see the 7-segment display and just the numbers. Some jobs take just that little bit longer. This drawing was started. Let's have a look at the versions here. Workspace property, where we look for this. No. I think if we go back here. Versions in history. So we started on 24th of December 2023. This drawing was started. So we've done all right with that. 6:04 p.m. on December Christmas Eve 2023. It looks like I got in and started drawing this up. I've been working on it. If we drop that down, there's a bit of a list of changes. So looking at this, January. Looks like the 12th, I actually did a fair bit of work on it. January the 11th, I did some. January the 9th. So back there, January the... We go through here. June the 30th, 2025. Just looking for an export. Give you some idea when I cast it, but anyway, not that important. We'll go back here, but it's a job that's been happening for a little while. Anyway, Donation box of files and bits up anyway. Where are we? Looking at this, we've filled up an hour very comfortably just looking at projects, and it's terrible. But here's our block plane, and this is where we're at. Will that be cast? I guess we're talking about the cover for cast in aluminium, I think. I'll print it and then cast it, and it'll be a nice job then. But I'll make a temporary one that looks like it's going to work and fit and everything in plastic, and then when we get it working, I'll cast one and machine it to match and screw that on, and I think that'll keep the water out. I think it probably needs some sort of lens on the front of it. I haven't thought that far through yet. Now, this is the hand plane that's close to being finished. We were working here on this crazy cap iron before. If we have a look here, cap. Come on, wake up. So this is what we ended up with here. We'll do a little bit on this. So here in the center, there's a, we'll have a look at it. We'll get some light, probably. Is that going to be any good at all? No, not really. Not helpful. Because we're sitting here in the dark. We'll go back to me again. And hopefully I won't forget to go back to there we go. That's not real good there. Sorry, guys. Why have I got light rays everywhere? Don't know. Anyway, this is the part. It's got a keyhole here in the middle, right? And it's got a bushing with a little cam piece that flicks backwards and forwards to lock it in place. And it's got a textured finish on here. It's got a patent number on it. I don't know if we'll go to that sort of trouble. But it's not a complicated thing, and it's close to being finished. There's also this shape in the bottom of it, if we have a look. I don't know if you can actually see that. But if we drop a ruler on it, and we've got a ruler, you can probably see there's a light gap under the front there if we have a look. There, you can see that there now, I think. So we've got to put that shape in there. And we've got to put this shape in the back here where this piece sits. And we've got to put a keyhole in it and some texture. Let's mess around and do that. Put the light off to one side for Peter says. It's never been a problem until tonight. Don't understand. Anyway, it's not really ideal. I did clean the screen of my Mac, and maybe that's not done anyone any favours. Let's have another go. I'm going to wipe you out here for a minute. I'm going to have to think about that. Don't know. Anyway, we'll go back to the CAD. So we've got this keyhole here, and we've got a shape. See, this hasn't got any of this shape here, so we could put that shape in. It's probably not going to be the first operation. Put that in the bottom here. I think we're going to put a keyhole in here first. Now looking at it, and I did bring a ruler up with me. We were working in metric on this one. So what have we got? About 23 mil to the centre of the hole. And the hole needs to be big enough for the screw to go through. So we're looking at about 10 mil. So easy enough. Let's put a sketch. We'll put it straight on the top plane. And circle. Got that yellow dotted line there, if you can see that in the orange dot, which means that it's lined up with the origin point. We can call this 10 mil. Let's call it. It is only 10 mil. We'll just pour 10 mil. Like so. And we'll put a measurement on it. So if we dimension that from there to the front, like that, it's 22 mil. It's done. It's got a keyhole slot that's about, what have we got, 7 mil. And it's about centre to centre, it's about, let's call it 9 mil centre to centre. So if we put a line, we press Q for a construction line. Q, not 1. That automatically highlights our construction line there. We can put a line back here, and we'll call that 9 millimeters long. Press escape. And we can put another circle here. Actually, we're not going to put a circle. We're going to save a couple of points and put a center point arc there. Around like that. And we're going to call that as a radius on an arc rather than a circle. So we're going to have to call that 3.5 millimeters. And that gives us sort of an idea how this works. If we draw a line from there through to there, press escape, and we can probably just mirror that, select the mirror line, and that one. Entities to be mirrored. I think we mirrored that one twice, so we'll start again with that. There we go. And then select the scissors and trim that there and there. Like so. Cut this bit out. And this bit, keyhole shape. Now it's got a raised ledge, which is about 1 millimeter. So the best way to do that is just to offset that all the way around, like so. If we've got a mouse picture there, and we can right click that to save that, and it comes up with a dimension. All we need to just type in 1, and it should work itself out. The tip drops down slightly. Maybe that's how it is. You're probably right. It's probably more that than the cutout. So there's our cutout. Extrude that from there through to there. I haven't got a clue how tall that is. Comes up a little bit. Let's see how 3mm looks. Three's not enough. Is it? 3 is enough. 2.5 is probably enough. Let's call 2.5. That's that. If we highlight this sketch again, because it's automatically shut, I think you can change that in the settings. I've never ever done that because there's pluses and minuses of why you should do that. We can do another extrusion on that sketch. So basically on the inner part there. And I'll go for reverse so it goes the right way. And there's our keyhole in place. Job's done. Now, I think this probably sticks up too far because I think to do a speckle on here, we need to drop this face down a fraction. So we can just use the move face function, which I've been using a lot recently, and faces to move 0.5. It doesn't quite work how it should though, so we might just leave that. Sketch on this plane here, which is that face there. See this. So that face, we want to put a diamond pattern on there. Now, ways to do that. First thing to see is the search tools. And we can search for pattern. No. I know that there's a tool for doing this. Let's have a look here. Rather than put a sketch on here, let's have a look here under this. Grid extrude is what we're looking for. Grid. Nope. have a look here. A knurl pattern, maybe. Diamond knurl is sort of what we want, I guess. It's trying. See how it handles this. It's using some actual processing power on the out on the grid somewhere. I mean, that doesn't look terrible, but it's not really what we want. That's getting a lot closer. Now we're starting to talk to it. Right. We'll see how it goes. Grid angle 45 degrees, Peter says. See, Peter's learning, yeah. We'll just wait for it to sort itself out, because I'm not sure how good my internet is at the moment. Bit sketchy, actually. I think I used all my bandwidth already, and I've still got, what is it, the 13th or something? So I've still got 12 days or something before it resets, and I can only change my plan, so I've got a bit more, because at the moment it's my mobile data is sort of what we're working on. So that looks all right. Now, measurements here. It's actually inverted. Let's invert that and see what it ends up with. It's taken a minute. I'm not sure how to make them points. Yeah, I'm not sure they are points. There is what we're looking for. Not that. Not that. Well, this would be very nice if this tool had a draft angle on it, but it doesn't, and I don't think I'm going to go to the trouble of putting draft angle on it. We'll just wait for it to process itself. There we go. What have we got? That looks a bit sort of small. Let's go 0.8. We're going to have another go at this. We'll get it right. Come on, we can do this. It's going to be okay. You can do this. You can do this. You can do this. Anyway, apart from that, did you get your parcel, Peter? I hope you did. I hope it arrived. I've just got a little turny head here. Could do with another cup of tea. Some point, come on, spinny, spinny, spinny wheel. You can do this. Come on. Hopefully that's done that. If I refresh this page. No, we've got an internet problem, I think. Let's refresh the page and see what we end up with. Oh, thank you, Peter. That's great. Come on. Come on. If my internet's going to be a poopy head, maybe we need to do something else. Because see, we've got a little E here beside this A connection, which is my sign in. It means that someone's editing this. It hasn't actually recognized that it's me yet. Editing that. You probably did. I think I've got a row of emojis. I think that's all I got. And I'm sorry I misinterpreted those or I didn't look at them. I assumed that's probably what they were. Let's go back to I got a message. All right. Loading workplace. Let's see if it does it. It might not. There we go. It's done it. That's not bad, actually. That's actually, for the amount of effort we put into it, that's not a terrible. I'm pretty happy with that. Good stuff. Thanks, Peter. So that's that. And I think that's we've sort of got that pretty good. It's not bad. It looks all right. It's not as good as Chirpy you do with all these fancy hand tools, but it's all right. So here on the center, there's a hole. It looks like, I'm guessing, looks about 3 millimeters. So we could just put a 3 millimeter hole in there. Put a sketch right on there. is a circle right on the center there. There we go, sketch planes there. Face of extrude 4, and then the center point there. 3mm circle. I think my internet's a bit ordinary here. Sorry, guys. It's going to just chase its tail, so we might give that a miss. But we've made a little bit of progress, and we've had to talk about stuff. There we go. There's a 3mm circle. We've still got the construction line there because we still had that. Then we can press that or press Q, and that changes it back to that, and we can extrude it. We'll click remove there. Come on, do the thing. I think our internet's going to cack out now. So we've got a hole in there. That's done. We haven't put the patent number around that hole. We're probably not going to be honest. This has got a lot more draft in the corners here. I wonder if we can do that. If we have a look here, we've got this feature here that's loft. Is that right? No. This one, draft, body draft, I think is what we need. Body draft these faces. Pulled her in. It's going to be that way. Now, I'm not talking, so that's probably why. You're not hearing anything. Let's close some of these. Just do the top ones for a start. There we go. Let's see if we can get a little bit of draft on this angle here. Is it going to do that? But it's not. Anyway, it's worth a try. Close enough. What we have in here is, well, we've got there's another feature that looks like this, but it goes around the back here. So we'll go to the top here. And it's in line pretty well, I think, with this circle here. So if we put a sketch on our top plane and we put a center point arc from that hole, from that there, something like that. Can you see that? Probably not. Probably 15 millimeters. Radius. And then we've got a radius around there, and you can see that. Probably if I light it up, you can see that. And then we need to use, if we use this project curve and use this one, what we need is a line, something like this. What we're going to do, Control Z to get rid of that. Undoing a change. This is getting a bit slow. Hey, James. Getting slow. I don't think we've got what it takes to do this with this and have it live streamed. It's decided it doesn't want to. So I might call it a night and get it finished, I think. I don't know. What I want to do is a clear and concise idea of what I want to do with this. If we select that and that, now we've got all these parts here. Why is that so? It's because all these are separate. Let's close that and fix this. That's why it's taken so long, because it's struggling with that. Let's do a union. Union, tools, all one piece. Part 1015. That's why we're having trouble with it. Well, let's let that work for a minute, and then it should be back to normal. It's struggling a bit with 1,000 parts. And it looks like that's sort of what we've got there. If we scroll down through this, 1,306 parts. A minute, but it should put it all together nicely, and then we've only got one part again. That should save us a lot of energy in the cloud. So we'll just wait for that to happen. But that's why we're having trouble with it. It's going to be something slowing it down all of a sudden. Anyway, wonder what James is up to. How's the moving going and all that stuff? You're all fixed. Wonder what the weather's like in where you are, Peter. It must be pretty warm. It's warm enough here. How's the tube plate going, Mark? It's all sorted, is it? Come on, do your thing. You could do this, guys. Come on. The cloud's got what it takes. Maybe. Anyway, talk amongst yourselves. James says it's cold. It's stinking hot here. It's supposed to be get a change tomorrow, which would be very nice, or even rain tonight, which would be nice. But we'll see how that goes. 33 degrees. That's probably colder than here, to be honest. We haven't got 70% humidity. We've got, it's dry here, I guess, hot and dry today. It hasn't really been humid. This hasn't been overcast. It's just been hot. I reckon it was probably 34 or something and hot here today. It says that Boolean 3 did not regenerate properly, cannot resolve entities. So we've got a problem there. Let's have a look at this grid. I'm going to start to load this again and see how it goes. Tropical flooding, tornadoes, hot, humid, 21 degrees F, snow. Excellent. That's everything. That pretty well covers it. Not totally missing very much there, James. You didn't say anything about hail, and you didn't say anything about you didn't say anything about flying fish. You didn't say anything about electrical storms. You didn't say anything about hail. And you didn't say anything about bushfires. I take it that's all good. I think I've screwed this up. For some reason, the two pieces don't intersect. And they should automatically have connected as one, and it hasn't. So as soon as we resolve that, we'll be back in business. But I might just let it work for a bit and close this and say, hey, look, we'll come back to it next week. It's getting fairly close to being finished. There's just that detail there with the little slider, and we've got it. But not a complicated. But anyway, thanks for watching, guys. I'm going to call this because this is going to take forever, and it won't do it while I'm live streaming, I don't think. So it's really giving the cloud a bit of a run for its money because we've done that. It's just silly. Rather sweat than freeze. I don't know about that. I'm dripping wet and I'm black. Like, seriously, I'm black because I've been, that dirty for the last day or so. Hopefully tomorrow I'm a little bit cleaner, but we'll see. Anyway, call it, guys. Thanks for that. Appreciate you watching. It's 9 o'clock. Thanks for joining in and keeping me company while I mess around anyway. That's about all this live stream was me messing around. And in the stream, and I'll let this go. And no dead ducks is good. And we'll catch you another time. We'll see you tomorrow night with a workshop update. See what's actually happening.